Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to vector product or cross product. So in the previous videos we discussed first the basic introductory concepts, then the properties of vector product, cross product, and then we extended our discussion to unit vectors and how we can apply the concept of vector products to find out the cross product or vector product of two unit vectors to get a third unit vector. So in this video we are going to discuss some important applications, okay, some important applications of vector or cross product. Okay, so first, the vector product or cross product can be used to find out the angle between two vectors. How? Now we know that the cross product or vector product of two vectors, let's say we have B vector and we have A vector, like this. The angle is directed from A to B, let's say it is theta. The cross product or vector product is given by this: A vector, B vector, sine theta, n cap. Now here this n cap is unit vector in the direction of the resultant vector. Okay. Now here the resultant vector is perpendicular to the plane containing A vector and B vector and is given by right hand thumb rule. So it is directed perpendicular to the plane here, A vector cross B vector, and n cap is the unit vector in the direction of this. Now the magnitude of this vector product or cross product is A vector modulus B vector modulus sine theta. So this theta part is very important here. The direction of theta determines the direction of the resultant vector. Now if it would have been in the opposite direction, the same resultant vector would have been pointing downwards, again perpendicular to the plane. We have already discussed that. So here sine theta can be expressed as A vector cross B vector modulus divided by A vector modulus by B vector modulus, and theta is equal to sine inverse of this whole thing here. So if there are two vectors, let's say if there are two vectors, A vector which is represented as Ax I cap, Ay j cap plus Az k cap, and B vector is given as Bx I cap plus By j cap plus Bz k cap, then theta will be sine inverse of the resultant, this magnitude of A vector cross B vector, which we have already discussed is the determinant. A vector cross B vector is the determinant of this I cap, j cap, k cap, and Ax, Ay, Az, Bx, by bz, that determinant. And A vector modulus, we already know it is the sum of the squares of the x, y and z components of a particular vector. This bx square plus by square plus bz square. Okay, the resultant vector that we'll get, let's say the resultant vector is cxi cap plus cyj cap plus cz k cap, let's say that is that, then the magnitude of that will be A vector cross B vector modulus, which is C vector modulus root over of cx square plus cy square plus cz square. Okay, yeah. Okay, this is the resultant, and that's the way we will find the angle theta between the two vectors. Okay, A vector cross B vector modulus, which is this resultant C vector modulus, and then the product of the magnitude or modulus of the individual vectors, A vector and B vector modulus here, sine inverse of that. Okay.